Intro. Welcome back to our channel. Today, we're diving deep into the world of AI and machine learning, focusing on how to build a production-ready AI workflow. With the rapid advancements in technology, it's crucial for data scientists and machine learning engineers to not only develop models but also ensure they can be efficiently deployed in a production environment. In this video, we'll break down the entire process into three key components: automating data preparation, model training, and deployment using continuous integration and continuous deployment, or CI/CD, pipelines. So, without further ado, let's get started. Section 1: The importance of a production-ready workflow. Before we delve into the nitty-gritty of creating a production-ready AI workflow, let's first understand why it's important. The journey from an idea to a deployed AI model involves numerous steps, and without a structured approach, the process can become chaotic and inefficient. A production-ready workflow allows for automation, consistency, and scalability. Imagine spending weeks developing a model, only to find out that deploying it is a convoluted task requiring manual intervention at various stages. This can lead to errors, misconfigurations, or even failures during deployment. A well-structured workflow ensures that every aspect of model development and deployment is repeatable and reliable, enabling teams to focus more on innovation rather than troubleshooting. Section 2: Automating data preparation. Now that we understand the importance of a production-ready workflow, let's jump into the first step: automating data preparation. Data preparation is often the most time-consuming phase of any machine learning project. It involves tasks such as data cleaning, normalization, feature selection, and transformation. To automate this process, we can leverage tools and libraries that facilitate data handling. One popular framework is Apache Airflow, an open-source tool designed for orchestrating complex data workflows. With Airflow, you can create directed acyclic graphs, or DAGs, which define the sequence of tasks that need to be completed. For example, let's say you have a dataset that requires cleaning, normalization, and some feature engineering. You could set up a DAG in Airflow that first runs a script to clean the data, followed by another script to normalize it, and finally a script that performs feature engineering. Each of these tasks can be executed automatically in a defined order, significantly reducing the manual workload. Additionally, it's essential to ensure that the data you're working with is consistently formatted and representative of the production environment. This is where data validation comes in. Tools like Great Expectations can be integrated into your workflow to validate data quality. You can define expectations, such as checking for null values or ensuring that specific columns meet certain criteria. Automating these checks ensures that your model is always trained on high-quality data. Section 3: Model training automation. Once your data is prepared, the next step is model training. Training machine learning models can be resource-intensive and time-consuming, especially as datasets grow larger and more complex. To automate this process, we can use frameworks like TensorFlow and PyTorch, which provide APIs for building and training models efficiently. One effective approach is to implement hyperparameter tuning. Hyperparameters are parameters that are not learned during training but are set before the process begins. Techniques like grid search or random search can be employed to automate the tuning of these hyperparameters. Libraries such as Optuna or RayTune can assist in this process, allowing you to explore various configurations automatically. Another critical aspect of model training is version control. Just like code, machine learning models should be versioned to keep track of changes and improvements. Tools such as DVC, Data Version Control, can help you manage datasets, models, and code efficiently. With DVC, you can create a Git-like workflow for your machine learning projects, ensuring that every change is tracked and reproducible. Additionally, setting up a training pipeline that can handle model retraining automatically is essential. For instance, if new data becomes available, you should have a process in place that triggers retraining of your model. This can be achieved by integrating your training scripts with Airflow or other orchestration tools, allowing for scheduled or event-driven retraining. Section 4: Deployment with CI/CD pipelines. Now that we've covered data preparation and model training, let's discuss deployment, the final piece of the puzzle. Deploying machine learning models can be challenging, especially when you want to ensure that your models are production-ready. This is where CI/CD pipelines come into play. CI/CD stands for Continuous Integration and Continuous Deployment. It's a set of practices that enable teams to deliver code changes more frequently and reliably. In the context of AI, CI/CD pipelines can automate the process of deploying models, ensuring that each deployment is consistent and well-tested. To set up a CI/CD pipeline for your AI model, you can use tools like Jenkins, GitLab CI, or GitHub Actions. The first step is to define your pipeline stages. A typical pipeline might include stages for building, testing, and deploying your model. For example, the build stage can involve packaging your model and its dependencies into a container. Docker is a great tool for this purpose, allowing you to create lightweight, portable containers that can run your model in any environment. The next stage is testing. Automated tests should be created to validate that your model behaves as expected. This can include unit tests for individual functions, integration tests to ensure components work together, and end-to-end tests that verify the entire workflow. By automating these tests, you can catch issues early in the development process. Once your model passes all tests, the final stage is deployment. Depending on your infrastructure, you can deploy your model to various environments, such as cloud platforms like AWS, Azure, or Google Cloud, or on-premise servers. Tools like Kubeflow can be incredibly helpful for deploying machine learning models on Kubernetes, as they provide a robust framework for managing the lifecycle of ML models. One important aspect of deployment is monitoring. After your model is deployed, it's vital to monitor its performance to ensure it's delivering the expected results. This can involve tracking metrics like prediction accuracy, response time, and resource utilization. Tools like Prometheus and Grafana can be used to visualize and alert on these metrics, enabling you to quickly identify and address any issues. Section 5. Putting it all together. Now that we've explored each component of building a production-ready AI workflow, let's put it all together and discuss best practices. First, document your entire workflow. This documentation will serve as a guide for your team and help onboard new members. It's essential that everyone understands the processes and tools used in the workflow. Second, embrace a culture of collaboration. Data scientists, machine learning engineers, and DevOps teams should work closely together throughout the workflow. Regular communication can help identify bottlenecks and areas for improvement. Third, continuously improve your workflow. The field of AI and machine learning is always evolving, and so should your processes. Regularly review your workflow to identify areas where automation can be enhanced or where new tools can be integrated. Lastly, prioritize security. As you automate your workflow, be mindful of security best practices. Implement access controls, secure sensitive data, and monitor for vulnerabilities. Security should be integrated into every step of your workflow, from data preparation to deployment. Conclusion. In conclusion, building a production-ready AI workflow involves automating data preparation, model training, and deployment through CI/CD pipelines. By leveraging the right tools and practices, you can create an efficient, scalable, and reliable workflow that enables your team to focus on innovation. Remember, the goal is not just to build models but to ensure they can be deployed effectively and deliver value in real-world applications. Thank you for watching. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and leave a comment below with your thoughts or questions. We'd love to hear from you. Stay tuned for more insights into the world of AI and machine learning. Until next time, keep innovating and automating.